Unbelievable stuff. Now that surely has got to be as wild as it gets. Pah! My dream is to fly through the sky, not just to fall, but to actually fly. And maybe even one day, maybe we could actually land without a parachute. Let's see what the laws of physics have to say about that. Now, if we're going to demonstrate the physics of falling, first we need someone who's prepared to fall. Second, we need some very technical people who are going to... What are you going to do? Are they going to make some measurements? And thirdly, we need a stopwatch, which is in the camera. I said first we need someone who's prepared to fall. I see, that's me. Now this is a deadly serious science experiment. We're not here to have fun. Let's see how fast we can go.
How fast was that?
We put several markers on the crane. They're at 10-metre intervals all the way up the crane, so we can help us gauge exactly how low Adrian comes with his jump and how much he returns to. On top of which, we've actually worked out on the calculator exactly, bearing in mind his weight and the stretch of the rope, the same thing, how much he stretches to and how much he returns to.
On the first descent, Adrian takes 4.4 seconds to fall 63 metres. On the second descent, he takes 4.7 seconds to fall 40 metres. And finally, on the third descent, he takes 4.3 seconds to fall 35 metres. Using the formula, speed equals distance over time, his average speed on the first descent is 14.3 metres per second. The average speed on the second descent is 8.5 metres per second. The average speed on his final descent is 8.1 metres per second. So Adrian's average speed depends on the height of his fall. As he falls, he starts to accelerate, so the shorter his fall, the less his top speed. The calculated speed for each descent is the average of his initial speed, which is 0 at the start of the jump, and his top speed. This decreases with each descent.
So the first conclusion is, the higher you jump from, the higher your top speed's going to be, which means I can jump from here without a parachute. It's not very fast though, is it? Now, if we want to jump off something very, very high, something extremely tall and live, we have to find a way to slow ourselves down. So this time, I'm going to jump like a base jumper, like a flying squirrel. Wearing this big suit, I'm going to try and catch all the air I can. Ready, steady, go!
By wearing a suit and jumping like a flying squirrel, Adrian is increasing the air resistance on his body. Air resistance depends on shape.
As I was coming off the top, I didn't get the rush of air coming past me quite as much. It felt much slower. Let's see what our technical experts think of that.
On the first descent, Adrian takes 5 seconds to fall 63 metres. On the second descent, he takes 4.8 seconds to fall 35 metres. And finally, on the third descent, he takes 4.2 seconds to fall 30 metres. Again, using speed equals distance over time, his average speed on the first descent is 12.6 metres per second. His average speed on the second descent is 7.3 metres per second. And finally, his average speed on the third descent is 7.1 metres per second. So his squirrel jump is slower than his normal first jump.